Our next speaker is Phil Owen with the Renaissance Computing Institute, and his talk is entitled iRODS Build and Test Version 9, Automation via GitHub and Kubernetes.
Hello, everyone. I'm Phil Owen. My title at UNC is Research Scientist, and my title at RENCI, is Software Architect, and I'm sort of in a consulting role right now, helping out the iRODS with this whole paradigm they want to shift to of testing their products in a much more efficient manner, shall we say. Okay, so what we're going to talk about, iRODS testing in general, what it means to test iRODS, the solution that we are coming up with right now that involves using Kubernetes as an engine to provision environments that will allow us to test in a very wide manner. We're really going to create a number of iRODS topologies and test them all simultaneously using Kubernetes. I'll also just briefly mention the impact of what this is going to have, and there are some things that have come to light after I put some of these slides together that this could also be extended to other things other than just testing that might be advantageous to other groups that are interested in standing up a whole bunch of iRODS topologies in a very short period of time. And the future vision, of course, where do we go from here? So everybody wants to look forward. So the motivation. Right now, the way testing is done is it's not very efficient. Virtual machines, I think there is some Docker and some Docker Compose going on. It's still very manual, and it doesn't really scale well. When you consider that iRODS can go onto a number of operating systems and a number of database management systems, you start to develop a matrix. Okay, so you got a 2x2 now, or 2x2, and now you put into the equation, you're running tests, you've got plugins, so now you're going an n-dimension matrix, and doing things like that by hand is not only tedious, but most likely error prone as well. So we want to make that process a lot more efficient. So we've learned how to automatically provision iROD providers and consumers in the Kubernetes world, so we can go very wide. We can scale this thing up to as much resources as you have on your Kubernetes cluster, and therefore test quicker and have a more repeatable and reliable environment to do your testing in. The other things, of course, are pretty interesting. Also, we wanted to have some sort of way of doing forensics and analysis on our testing. Each test creates a number of log files and things like that, and output results. And I've actually started developing a forensic component where we'll go through and look through those some of that output and summarize it for the test requester. And something else that will probably be helpful later on is that we can automatically provide code certification. So if you have a component that you've built and you want it to get into main, then you have a way of proving that it's worthy. So here's the infrastructure overview. First, it all starts off at GitHub. Somebody posts some really awesome code to GitHub, and once the push is there, GitHub action activates, and then it does four things. First thing, it links the code. Style issues are warnings. Warnings are errors, and errors are fatal. Okay, so we're already controlling the quality of the code that's coming in. The second thing that happens is the code is used in that branch to create iRODS packages, and we're going to use those packages in our Kubernetes environment. I'm sorry, see, I keep walking around. And then once those packages are created, they're moved to a common place where the Kubernetes server can get at them, and then they're used in some of the other components that I'm going to talk about coming up. The Kubernetes cluster, of course, excuse me, the Docker container image registry, that's where we're going to store all of our operating systems, all of our database management systems in Docker containers, Docker images, and those will be pulled based on the test request parameters on how to build up your iRODS environment. Web-based interfaces, there's currently 2 right now. One is to provide web services that gives access to all of the components that are managing this whole process, and another where a user can manually request a test. And they can select select the parameters of the test and just let it go, and then you get to see what happens. The application supporting services, they're all, and all these services that we're talking about here that are part of this whole application are all running inside of Kubernetes, so it's sort of self-sufficient. Everything is running in one spot. And of course, there's file systems involved here where the test results are placed and available from the web services will actually pull the test results, forensics and things to the local client of the person who made the original test request. So here's the big picture. So I've just told you about some of these components, and now we'll talk about how the process works. So it starts with a developer or tester, and you know that's an iRODS developer because they're green, right? And so they're interfacing with their development environment in the GitHub and GitHub Actions. And I told you that the GitHub Actions are checking for code viability. They're checking to make sure that they can make packages out of them, and they're placing those packages in an iRODS package store. There's a line here that's missing. I'm sorry, but there's a line that goes from that iRODS package store over to the Kubernetes cluster, because the Kubernetes cluster is going to want to get at those and start installing them. The developer could also make a test request manually. He tweaked something and just wants a quick test request, or he lost his last run forensics, so he can actually make another test request manually. The development environment the what? Oh, technology, right? So the user has his own development environment, and that'll also have access to the Kubernetes file system, just so we can get off some of the things that the metrics and those sorts of things that might have happened during the testing of the component. All these guys are all connected with web services, so they're all talking to each other. When a GitHub action makes an iRODS packages, it will issue a command over to the web services to start a test request automatically. It's kind of cool, right? So the web services are interfacing with a database. There's a user interface, the FAST API, and some of you might be familiar with that, that also is actually hosting the web services, and there's something a human can use to actually interface with some of the systems that are going on here. The database management system is what contains all of the configuration details of the workflows that I'm going to talk about in a moment, that are managed by the Kubernetes job supervisor. Here's the Docker image registry. This is going to house all of the images for the operating systems and database management systems. So a user can pick and choose which combination they want, right? And I know that's important, because if somebody says, I've got this bug and it only happens in what? Oh, jeez. To follow this thing around here or something. I'm sorry. So getting back to what I was saying, so there's all these combinations that you have that of operating systems and databases that you can quickly create, and you can try to replicate the problem that has just arisen. All right. So it's one of those things where now we're getting really close to almost real-time repair of of components. And of course, that's all running on the Kubernetes cluster down here in the corner, right there. And RENCI has an on-prem Kubernetes cluster, and I also have access to one at UNC, University of North Carolina, and I have another one in Amazon EKS, AWS EKS. So I got this slide up here for Kubernetes. I encourage you to go look and just kind of follow up on Kubernetes, because it's a really good replacement for those old fat virtual machines that you're probably all still using. Okay, and it's a much more resource handler. Excuse me, a better resource handler than a VM is, because you're not installing all kinds of fluff that you don't need. Kubernetes, and I've already been saying it. K8s. It's also, some people call it Kates, right? It's tough to say Kubernetes all the time, right? So they've shortened it. They've taken 8 letters out of the name. So, yeah, that's that. And then, so here's the traditional deployment versus virtualized deployment versus container deployment. And that's what we're moving to here with Kubernetes. We're moving to the container deployment. The container runtime is much more efficient than the hypervisor is or was. So you end up you're getting more bang for your compute node bucks, if that makes sense. So let's talk about the application services that make up this whole testing environment. First, the Kubernetes job supervisor. This is a workflow engine. Now, what this component does is it will take a number of workflow steps based on what your test request is, because you could ask for just a provider or a topology that has providers and consumers in it, right? So, and you can make topologies that have 8 consumers and 2 providers and start a federation or do anything of that nature. And they're all defined as workflows that are actually defined in a database. So we can add more and tweak some to create these workflows that will create these test environments. The supervisor settings user interface, that user interface connects to the database, and the database has all the configuration parameters for the job supervisor. So you can dial knobs, and it also allows you to adjust the resources that are used in each pod, each container, each image. In the choose for the job request. This is the user interface that I mentioned in the database. And we also have some cron jobs that run in the background so that like the database backups and those sorts of things, archiving of data. iRODS testing. These are some of the features that we've built into this job supervisor. I'll let you guys read those in your spare time, but basically it's programmatically interfacing with the Kubernetes server using the Kubernetes API to talk to it, to make all these jobs and and spawn all of these processes. Quickly, this is basically the flow of data through the supervisor. You get a testing impulse, a test request impulse, goes into the job supervisor picks the right workflow, gets a whole bunch of steps, and it starts initiating Kubernetes jobs. The Kubernetes jobs create pods, or representations of the Docker images. If it goes to the next step in the workflow, it's successful. Otherwise, it'll drop down to the next active request, and then any data is persisted to the file systems. So each supervised workflow type is a series of, it can be equated to iRODS topologies. You can have a database and a provider. You can have a database, a provider, and a consumer. You could have a database provider and 9 consumers. So you can basically build up an entire topology in just a matter of minutes. The workflow steps that we've currently defined for some of the workflows starts with data staging. So you're getting everything prepared for the testing. The database is started, a provider is started, a consumer is started, And each one of those, the provider and consumer automatically start running tests that are specified by the user. After the tests are all done, another process comes in and does the forensics, where it's actually pulling out that data, that logs, it's summarizing some of the information. And I've got some ideas on how to make that a little smarter. And then finally, the final data staging, where all the old data that's no longer needed is removed from the system, so it cleans up after itself, and it archives whatever into a zip file, so that it's tight package and that can get emailed around or what have you. And you can also pull it off of the settings website as well. That's another web service endpoint. So the positive effect, of course, we have a working version of this, and if you come to my talk tomorrow at 4 o'clock, I'm going to actually demo some of this stuff. It's quite interesting to watch how it figures out all that stuff. And but what this really brings to the table is that automation is key. We get a repeatable environment. We got a way to reproduce environments very quickly, so there you have it. I mean, it's a much better way of preparing iRODS for releases. And we got some future stuff in here, all the pie in the sky things that everybody always talks about, and keep that later. Okay, and here's us. Here's the team. If you download this, or get a copy of this, there's all kinds of stuff below here. And all of my source code is available, so you can go look at it. It's been a known cure for insomnia. And but I encourage you to look at it because I think it's pretty innovative. All right. Any questions?
All right.
Come on. There's some questions.
Got a question here?
Run, Derek, run.
Yeah, this looks nice. You can test a lot of different things in containers.
Yes.
Do you also run production in containers?
No, but you can. No, but you can. There's nothing to say. See, right now, these processes come up, they do their test, and they jump out. There's nothing to say that you couldn't create another workflow that doesn't jump out. They leave them running. So you can have them, have your way with all these topologies, if you like. So it's, yes. And that's one of the things I'm learning now that would be very beneficial to the community if they were, say they were thinking about upgrading to another version of iRODS. System like this, you can stand up 100-seat, 100-client topology with a whole federated environment and try this version and hook it up to some of the file systems that you're currently using and just see how it goes. And if you don't like it, then you can just remove it. I mean, it's from Kubernetes, so it's very, very, very interesting solution to iRODS.
Thanks.
All right, we'll take one more question in the back.
Hit me.
So if there's all these advantages to using Docker, why are we not using production Docker deployments?
Well, I'm not sure I understand the question.
Why not use Docker for Kubernetes for production then?
I don't see a reason why you wouldn't.
Yeah, but you said that you don't do it.
With the not doing it now, there's a number of things that we still have to work out that are very specific to operating systems that Kubernetes is not dealing with properly. One is the rsyslog stuff. Rsyslog wants a very low process ID, but Kubernetes isn't allowing us to do that. So we're having problems like restarting rsyslog and those sorts of things. So there's still a few things that we have to work out, but we're very nearly there, and you'll be able to see tomorrow exactly how close we are.
All right.
I mean, you could move to an environment, and I presume that a lot of these exist already. It's a virtualized environment where you have all your iRODS servers and your iRODS topologies that's serving it out. Move that all into Kubernetes, and you can go way wide on how it's fed, and with resources and those sorts of things. So this is definitely a paradigm shift of how you work with iRODS, in my opinion. Corey might hit me over the head in a few minutes because it's the wrong one.
No.
But there you go.
All right. Well, let's thank Phil.
Sorry I went over.